Wheat School on RealAgriculture.com is brought to you by Syngenta Canada, Alberta Wheat Commission, and C&M Seeds.
Welcome to Real Agriculture's Wheat School series. I'm Kara Oosterhuis. In this episode, I talked to Dr. Susan Boyetchko, who is a research scientist with Agriculture and Agri-Food Canada in Saskatoon. We talk about biopesticides, what exactly they are, as well as what research she's been doing with them in regards to grassy weeds such as the wild oat and the green foxtail.
So it took some time. It was quite challenging because there are a lot of people working on fungal bioherbicides to control broadleaf weeds, but there was no one doing a lot of work on grassy weeds. And it seems that to control it with fungi, you need to attack its growing point, you know, and we weren't finding anything that was significant. So we went underground, so to speak. And so we got a number of bacteria. We established a culture collection, but one of our best performers was this strain of bacteria that we started developing. We applied it as a granular application, you know, which a lot of the farmers, you know, the industry sells, and the farmers apply granules as a pre-emergent herbicide. So now we've got bacteria that inhibit germination and root growth elongation. And once you do that, then their emergence is basically they don't emerge. They can't survive. And so we've applied this granule that was using this originally this pest formulation. It was a technology developed by USDA scientists, but it needed some tweaking in terms of how it can release the bacteria into the soil and really get to its target. And there are a couple shortfalls in terms of the pest formulation. So we have to really look to industry to look at, you know, what are some of the formulations they can work with. And right now, a lot of their formulations are applied to with chemicals, and that's where the incompatibility is, because we're working with living organisms. So we've done a lot of work with fermentation, how to mass produce them, how to grow them up. And it's cheap as borscht, so to speak, if you want to use that terminology. You know, it's very easy to grow, but the formulation is the key. And we have to get that figured out yet, because we have to look at, is it stable? What is the shelf life? And in a granular formulation, the shelf life of our bacteria is 18 months, a year and a half. So that's really good. That's very good. And so, you know, we have to be aware of when farmers buy their product. It could be stored in a shed someplace out in the field or where it's really warm. And so we have to develop shelf life that's compatible with those kind of conditions. So we've got bacteria that have novel modes of action. They can be sprayed and can control chemical herbicide resistant weeds. And they're all novel. We got a couple patents on that, a Canadian and US patent on that. And so we really got to start making it being very compatible with existing farm management practices. But we've done our homework in terms of understanding what it does or what it doesn't do, how safe it is. And really we have to work with the regulators, the Pest Management Regulator Committee, the Pest Management Regulator Agency registers our product, and if it doesn't meet their specifications, such as human and health safety, they look at toxicology. Is it safe to birds? That sort of thing. Does it attack other crops? You know, other weeds? We do know that it attacks mostly, you know, annual grass weeds in preliminary studies, but we worked a lot more with the green foxtail in this case, and we'll extend it into wild oat. But it seems to be safe with cereals like wheat, barley, that sort of thing. We've applied it into a wheat field and it doesn't do anything to the yield of the wheat. We've applied it to pulse crops. So we've applied to about 17 different crops that are grown in the prairies, and it doesn't affect them.
So can you touch a bit more on the success and results you've seen? Because this is a mature research project.
Yeah, it is a mature project, although from an industry standpoint, for them it's only the beginning because they got to develop their technology and in how to formulate it and how to make it into a commercial product. Yeah. So we've, actually I've been working with a commercialization group within our organization, and we put out an expression of interest to companies and had a list of companies that might potentially be interested, and 24 companies expressed interest. Some are multinational, but surprisingly the biopesticide industry is really governed by a lot of smaller companies, small to medium-sized enterprises. Unfortunately, they don't have, the deep pockets. And so we have to kind of look at, the government has a funding opportunity where we can ask for the company to provide so much, and then the government will match the funding in order to get the job done. So we can work collaboratively with industry in order to sort of run down the home stretch, so to speak.
So any ideas when farmers could actually be seeing this out?
I wish I could say. Farmers are always asking me, or they ask me, how much is this going to cost? And of course I don't know that, because it would be the company that would be at the end of the day assigning a price point on that. And of course they want to make it compatible with other industry products in the herbicide field. But I think the more we have products kind of out and available, it'll be easier to do that.
Can you touch on what sort of effect this would have on herbicide resistance and things like wild oats that are group 1 resistant in lots of areas?
Yeah, it would have a big time. It will provide organic farmers with a way to control their wild oat and green foxtail, for example, which are 2 most important grass weeds in the Canadian prairies in terms of abundance and distribution. But just even to manage, like to look at conventional agriculture and to manage herbicide resistant weeds, that would go tremendous. It doesn't mean that resistance to biopesticides will not occur. It just means that it might be slowed down if you start combining it with other weed management tools and with other chemical herbicides. Then that would go a long way to actually delaying the onset of herbicide resistance. And if we've got our bacteria for the grassy weed project, we've got bacteria that have more than one mode of action. So then more than one mode of action means that they'll be delaying the onset again of herbicide resistance. So that's exciting.